I thought it would be good to select some of the slides from the 246 slideshow to show you guys today. But I want to avoid you thinking that you're responsible for all the details on those slides, because you aren't. But I think that that's not the point here. Like, it's not the point to distill down the slide set to just like the 5 or 6 slides that you're responsible for, because you need a decent story. Otherwise, this area will not be interesting to you, and otherwise it will have no entertainment value. You won't have any stories to tell, and you won't like find any of the sub themes here fascinating and so on. If we just distill it down to the stuff required for exams. So what I did is, from the first part of a PowerPoint, sort of pull out kind of the high points. And I was quite frustrated by the fact that we don't have the template master for this PowerPoint. It's a beautiful PowerPoint, but it looks so ugly without the master. So I thought that would actually dissuade you from ever doing anything with quantum biology again, that the design of the slides was so horrible. So anyway, that's the background for why I created a new PowerPoint for these slides. So any questions in what you've encountered thus far in the existing videos, like burning questions that we must answer immediately for you to become comfortable, or are there really no questions like that?
I didn't understand a thing, so I don't know.
See.
But I found interesting that quantum biology is trying to link the study of really, really small, I don't know, things to how biological systems work.
Right.
There was a slide at the very end that said that in a way quantum mechanics wouldn't be applicable to biological systems, because the way we study quantum mechanics right now is in really, really cold environments, in vacuum states, which is completely against where life happens, right? So how do they go around that?
Well, first of all, the slide I'm using as a background, as Simon said, a lot of things we depend upon every single day are quantum dependent, don't work without quantum. So it's not true that it only applies to like tiny microscopic things. On the other hand, nanobiology, nanotechnology has always been a part of the course. And this term, we don't actually have any lectures on it. So the quantum biology considerations also take us into the area of nanotech, the world of very tiny things, and how that world relates to the rest. Let me just see here if I can. Yeah, like Richard Feynman, you're really missing something if you're not sort of a fan of his and getting to know about him. I mean, he's a really cool guy. He played the drums, if you can imagine. There's all sorts of fun videos of him doing very enjoyable things, playing the drums and talking about stuff and so on. All right, so that's not what I want. What I want is this. So it is not that the guy in this picture, that recognizing him will be on the exam and so on. No, that's not it. It isn't that you'll do less well on the exam if you don't know anything about Feynman, but your whole life will be less enjoyable if you don't know about him. You're like missing major endorphin flow and stuff that will come from getting to know about him. So that's important, not because we require it in the course, but just as part of your life. You've got to know about Feynman. And so that's what I feel about this part of the course. If you can kind of wrap your head around the difference between the things you must learn because you owe it to yourself, because it makes life more fun and more enjoyable, and the formal requirements for the course. Because the amount of this that you're required to know for the midterm and so on is limited. But the amount of this that just makes you a cooler person and allows you to enjoy life a lot more because suddenly you're introduced to these concepts, that is a huge part of this. And so that's, and the things that don't make sense. I mean, if you think about what Einstein said about quantum and so on, a lot of it doesn't intuitively make sense. Like tunneling doesn't make sense. Superposition doesn't make sense, but that's just the way the world is. And it affects many macroscopic things, not just microscopic things.
So are you, could we say that not because we cannot measure it today is that these things are not happening? It's just that our ability to study them currently is not there yet.
Yeah, yes.
Okay.
Yeah, I think that is correct. And so we're trying, like, I think back to my own days in undergraduate. So at Oberlin College, I took a course in physics that was known as poets physics, right? Physics for people who weren't going to go into physics. And so it's somewhat similar to what we're trying to do here. So it was a very enjoyable course with lots of narrative and cool stories about science. But it didn't get deep into formulas and calculations and, you know, stuff like that. It was not trying to make me into a physicist. And here we're not trying to make you into a physicist. We're trying to expose you enough to physics that you will know enough about it to kind of know at least what questions to ask. You won't necessarily have the answers, but you'll know what are the questions to ask. And it also puts us beyond a lot of other futurists giving courses where they don't talk about this stuff, right? Because of you know, the natural resistance of your reasoning mind to some of these things. You know, Schrodinger's cat being both possibly alive and possibly dead at the same time, you know, those things just don't make sense to your logical mind, but they are a part of the the world of quantum. So we want you to know about that. So does that make more sense then? You know, your obligation to this course is limited, but your obligation to yourself is huge, right? You know, you don't want to just bumble through life and miss the really cool stuff, right? That wouldn't be good. So that's our main aim here, to make sure that that doesn't happen to you.
I have a question about the intelligent cell.
Yes.
How does that link to quantum biology? Because I found that slide a little bit out of place.
Well, there are many slides. I mean, there are 246 slides, right? That's a lot of slides. And it's like, yeah, so the intelligent cell, many people are like, there are algorithmic models of the cell. They don't work very well because they don't have enough elements yet. Someday, with the help of computers, we'll have models of cells that actually function like a cell. And right now it's a little bit clunky. But yeah, there are many things in the slide set that touch upon other very interesting topics that you may want to explore further. And the intelligent cell is certainly one of them. And I think I only got through slide 40 or something, right? So this is just the beginning of Jack's PowerPoint. And I don't know what happened with the slide master, because last year, the whole slide set worked when I originally got it. So something happened, but in a way, it kind of protects the intellectual property contained therein. Like if one of you wants to go out and pretend to be Jack Tazinski and give this thing, you won't succeed because the slides are so boring, right? Where's the cool background? We've seen Jack's lectures, and you know that the visual imagery is really satisfying. So that's the other side of it. You might say, well, why should you watch any videos? Why not just go through the slides? And the answer is that it's just way cooler to watch it on the video, because the slide version of the slide is way better than what you have. It's as if we took everything interesting visually in the slide and sucked it out and gave you the rest, right? Yeah. So anyway, that's what we have here.
I had a quick question too.
Yeah.
So in terms of the midterm, you mentioned in your email that we were responsible for knowing like 4 topics or choosing 4 topics to answer.
Yes.
And that there were 7. I was just wondering what those areas are. I just literally had time to start watching a video, so I'm just trying to figure out like how to group all the content together in my head.
Yeah. Well, so you might think about, well, what would the big picture here be, right? I mean, why are we studying this, you know, and so on. So there's an analogy between classical physics at the turn of the century, between the 19th and 20th century, and quantum physics now, right? Classical physics back then, people were thinking, we're done. We've solved everything. You know, this is now complete. Nothing more to be discovered. Everything has been, every cool statement about physics has already been uttered, and this is it. It's solved, right? And sometime we'll feel that about quantum. I mean, sometime this century.
Yeah. So it's in the minus. Minus 20. Okay. Thank you.
Sometime this century we'll be at the same point with quantum physics, maybe, of feeling that everything's now solved and so on. That would mean that we understand gravity and you know, dark matter and a bunch of things we don't really understand at the moment. But when we do, and maybe when we figure out what's going on in the clouds of Venus, you know, if there really are organisms living there, how do they function? Do they proceed by the same rules as life on Earth, or is it completely different? You know, when we sort those things out, we'll probably be at the same state with quantum that we were with classical physics at the beginning of the 20th century. Just a minute here. So, so that's one big picture. What state are we? Why should anyone care about quantum, you know, stuff? And then what are the basic differences between quantum physics and classical physics? What, you know, if you had to kind of define what are the basic differences? All right. All right, just a minute here and I'll have some more insights. Been kind of an interesting day. The first PowerPoint templates I tried were so terrible. They like made the slides completely unreadable and they blotted out half of the words on every single slide and so on. So anyway, I thought, what an idiot I must be. I must be choosing on purpose the worst PowerPoint templates. So anyway, thanks to Kaylin for getting us out of that. Okay, so like what are the key differences between classical physics, quantum physics? And then what are quantum effects in like the human body or in, you know, biological processes? Why is quantum relevant to medicine, right? So what are the main objectives to using quantum physics in biological systems? And then what are a few features of quantum mechanics that would be useful in biology? And then the scaling laws, allometric scaling laws. Now, you may not know what that is yet, but it's kind of cool. It's like how to do the way a really big animal lives and the way a really small animal lives. You know, how do these things compare? And then how are machines different from living creatures, you know, and so, and how efficient is the human body or biological structures in general in terms of you know, how efficient a machine are we? How many watts is the human body? How many watts is the human brain? You know, are we like a little light bulb, a big light bulb? Can you read by the light from the wattage that we are? You know, yeah, just things like that. The amount of power consumed by the human body and average by the brain. So those are the kinds of big picture things that we would like you to know about. And it seems to me those are also the things you would like to know about, right? You don't want to get deep into the details of the formulas of various things or to know why Einstein concluded this or that. Your brain is different than Einstein's. It's a little bit more limited. So there are like logical leaps that he made that you'll have difficulty making. that's okay. We're not trying to teach you all that stuff. We're not trying to recraft your brain so it's like Einstein's brain. We're just trying to give you little insights into stuff here. So, Simon, what do you have further suggestions about this? These general
I mean,
things?
just onto like Eduardo's question. I think he was talking about the differences, like how is quantum mechanics like applied to life. I think there was like 6 points, right? One was like life is big, whereas quantum mechanics is like small, like photons and electrons. And then life is hot, while quantum mechanics is like cold and isolated. And then there was like life is wet, while quantum mechanics is like in a vacuum. And you always want to try to actually isolate it from the environment. And then life is really slow, whereas quantum mechanics is measured in like milliseconds. And then life is complex, whereas some people say because quantum mechanics can entangle, it's more simple. And then finally, life is like real and it's local. It's like right here, whereas quantum mechanics is like uncertain. There's like the Heisenberg uncertainty principle. So those are reasons against quantum mechanics existing in life. But then there's like real world examples of quantum mechanics existing in life, such as our vision, like the retina, is like a quantum mechanical effect. So is our olfaction, like the way we smell, is also quantum mechanics. I actually did a lecture on that, not a lecture, a presentation on that, and it was actually quite interesting to learn about. And then some people say our mitochondria's metabolism might be also quantum. I think perhaps the most interesting one was when Jack Kaczynski talked about the human memory, like how do we store memories? He suggested that, you know what the centrioles are in a cell? Usually they're used in like replication. They like pull apart the centrioles. But he said that we store long-term memories by the organization of centrioles inside neurons, which is kind of interesting, right? Because then it's like a physical structure and it's the organization of those centrioles in our neurons that give us memory. So those are some examples of like real world examples of quantum mechanics existing in life.
Yeah, I also saw that the centrioles apparently react to infrared emissions as eyes. So that also was linked to the intelligent cell. And one of the premises of the lab that studies the intelligent cell was that we're doing medicine wrong, because each cell is able to collect its input of its environment and then react accordingly.
Yeah.
And in medicine, the way we deliver medication is, oh, here, all the cells have this dose of, or like this massive dose of this medication, right. Whereas what they are suggesting is, okay, just give it to the one cell that really needs it, right?
That's a great point. Yeah, it's like we're just dumb and just blanket carpet bombing all the cells. Wow. Yeah.
Anyway, interesting.
Yeah, very interesting. Good point. Yeah.
Making notes for my own exam. I hope it helps.
Yeah.
But let me also point out, this is a kind of a do-it-yourself part of the course to a certain extent. Like, you may feel for your own well-being, for your life to feel in balance, that in the first 40 slides, I've picked the wrong ones. The most interesting slides for you would be something else. So you can easily fix that. You can take this beautiful template that Kaylin has found and insert the slides that you want in it. They'll automatically become part of that, templated slide set, and you can make your own slide set. And it will contain many slides with details where you do not need to know that detail for the midterm or as a requirement for this course, but maybe those details are so fascinating to you that, it'll start you on a whole other intellectual journey that will be very productive, So that's sort of what I feel. Like, the stories here are very rich and surprising and counterintuitive and interwoven and all the features. If your life doesn't have enough drama up until now it's going to get it from these 246 slides, right? But you can decide which slides fit in your slide set and which don't, like maybe some areas are completely boring to you. But it's kind of like becoming an adult. I mean, how do you define that? You say, well, it's delayed gratification, right? If you're able to, not immediately have, but there are more things. And I think part of it is not just doing something because it's an external requirement, but to a greater and greater extent, you're in charge, right? You've got a trajectory for a long life. And there's certain things that you want to get done and want to get out of it, and kind of, your well-being depends upon certain things happening, right? And so some of these slides could give you new sources of, well-being, endorphin flow, and so on in areas of intellectual inquiry you had not previously considered. So that's how I look at it. And that's a very adult thing. When you were a child, you wouldn't really take on some big project probably because you wanted to enhance your life or something. But as an adult, that becomes a thing, right? It's a thing you can do. Yeah.
So one of the concepts, because I watched the condensed lecture, so I don't know if he actually touches on it in more detail, but he talked about how he said that if we were to actually give an answer to supernatural or paranormal activities, it would be quantum mechanics.
Yeah.
So is he kind of like, what I got out of that is like quantum tunneling could just be like the human version moving in ghosts?
Well, yeah, I mean, it's as surprising as ghosts. Ghosts don't really exist, but quantum tunneling really does. So that's the difference. Quantum
I mean, you
tunneling
don't
is
believe that
real.
ghosts exist.
No, I don't believe that they exist. Right. Yeah. I also don't believe in like the, Easter Bunny and Santa Claus. And if any of you still do, I'm terribly sorry to break it to you that I don't personally believe in those things. So yeah. Anyway.
I believe that if you can't disprove it or prove it, you can't say either way. So
Okay.
I can prove Santa Claus isn't real because spoiler, it was my parents, but ghosts,
Yeah,
I don't have any proof that they're not real.
Right. And there do seem to be, I mean, being a haunted house or a haunted, environment, or being a part of the ocean that a lot of planes crash into, and there's all sorts of types of haunting, right? And we don't really, there certainly are forces in the world, for sure, that we are completely unaware of. We just don't know that ghosts and haunting are part of something real that we're unaware of. But there certainly are things like that. Yeah, and so we will discover that.
But at some point in the past of human history, we were unable to explain certain phenomena that today we can explain, right?
Yes.
And maybe quantum mechanics is a tool that we can use to explain phenomena that right now we do not understand. Maybe 200 years from now, our descendants will be like, oh yeah, that's easily explained by X formula by Simon Wu, like something like that, right? So I guess that asking the right questions right now can begin the process of answering some of these unexplained phenomena, maybe not by us, but by whoever takes that research, right? So
Yes.
that's what you're trying to,
Yeah.
that spark that you want to give us at the moment.
Yeah. So I recently had an insight that I don't know if you'll find this valuable, but I think that it's true that like famous authors and celebrities can say things that stop the human race in their tracks from trying to figure that out further. Like when Yuval Noah Harari said, and he doesn't say this anymore, but when he said that all human culture will be wrecked by the fact that we won't make decisions ourselves, we'll go to machines, people didn't argue with him. And said, oh, well, that's it then, all human culture will be wrecked. Well, that's a pretty disappointing statement. If you're human and you're looking at this future trajectory where our entire culture worldwide will be wrecked, right? And so it's simply not true. As I pointed out, if this added intelligence would allow machines to so correctly answer every question, if that exists, then the same intelligence would allow us to have multiple instances of ourselves. So FOMO is gone. Anything you want to experience, you can with either your biological self or some, digital version, and then come back together in the evening and have parties with all your very compatible instances of self, right? Similarly, Leonard Cohen, when he said, if I knew where the good songs come from, I would go there more often. That suggests that that's unknowable, right? But what are good songs? Don't they have a resonance with like our communal unconscious, right? Whatever makes us similar in our thought processes. So that makes a song appealing, right? And now you can look at what are the really appealing songs and what common elements do they have. And so you can begin to access these areas that Leonard Cohen's statements seem to suggest you can never know, but that isn't true. So that maybe that would be freeing for you to think there are probably other statements like that, from famous people that seem to suggest an absolute limit in what humans can know. And it's simply not true, that there is no absolute limit like that. So you could take some area of your own life where people believe that something or other is unknowable, cannot possibly be ever understood, and simply reject that idea and go ahead and find a way to actually understand that thing. Yeah, so anyway, I just wanted to empower you by saying that's possible for you guys. You can do it. Yeah.
Just on to Ashley's point, have you guys heard of the Occam's razor? Have you heard of that idea? So what Occam's razor is when you try to explain something, the most likely truth is the simplest explanation. So that's what Occam's razor is. So, I mean, quantum mechanics sounds pretty complicated sometimes, so maybe it doesn't quite pass Occam's razor, but maybe there's no other simpler way to explain it. So, like for ghosts, to explain ghosts, I'm not sure how one could explain that, but like they can somehow travel through walls. You'd have to come up with a really complicated explanation. And the more complicated, the more unlikely. So that's Occam's razor. And then there's another thing, which is such a bizarre name. It's called Newton's flaming laser sword. I'm not making that up. If you search it up, it's a real thought process. But what the Newton's flaming laser sword says is that if you can't experimentally test something, there's no point thinking about it at all. Which, I mean, that's just a more, I mean, both of these are just not rules, but they're just ways of thinking that help us guide us to the truth, I think.
Right. So,
I just want to.
Taryn doesn't have a microphone, but you'll see in the chat that she says, if you're interested in thinking more about ghosts and science, you can check out CHRTC 350. You don't have to be religious to get a lot out of it. He distinguished between the metaphysical and physical realms and suggests that they require different methods of examination. For instance, taking physical measurements should never fully answer metaphysical questions such as what is love? As an aside, perhaps quantum phenomena could help us reconcile the metaphysical and physical. Who knows? Yeah, so I've given voice to the voiceless there because Taryn doesn't have a microphone today. Yeah. So what I basically wanted to do, and maybe I've succeeded, is give you a kind of pep talk so that we've kind of considered to some extent the first 40 slides. You only have 206 to go then. And yeah, so like for next Tuesday, I'll also put some others in a PowerPoint for you to consider. But this isn't some sort of limit. And really, by deciding to take this course, the decision to take LabMP 590 proves that you already know that the aim of life is not just to do what other people tell you, right? And to do what's required for tests. Because if you thought that, there would be no reason to take this course, right? This course isn't required for anything. It's sort of beyond what the current requirements of life are. It may have absolute survival value in the future. You'll be the only one that knows cool stuff, right? That may be very relevant to the future world. But yeah, so just thinking about how you came to the decision to take the course, it does suggest that you would understand an area of the course like this, where you have a lot of options of how deeply you're going to look into this area. And even though the exam does not require you to look into it deeply, maybe your requirements for your own life do, It's way better if you pursued certain areas of the 246 slides deeply. So does that make sense? Any questions about it? I would point out something about the template Kaylin found, and that is that I've written about young people today like templates where you begin with a complete white space and then add stuff to it. Whereas the old style of PowerPoint, you can still commonly find, is where you have an absolutely solid, usually dark color, and then the content that you add subtracts a little bit from that uniform dark color. So that's the way PowerPoint templates back in the 80s and 90s used to be. So what Kaylin found is more consistent with the enlightened view of what PowerPoint template should be like.
I have a question. So next class, are we going to base the entire discussion on the PowerPoint that you sent? before?
No. I mean, if you wish, we don't have to spend any of it on the, no, and not at all. I think that you can decide how we should spend the time. And the other part about adulthood is you don't have to show up at all. Like if you found today so lacking in intellectual value that every moment listening to me talk like sucks the vividness out of your life and makes you deeply depressed, then you don't have to show up on.
Because I just looked at the syllabus. Simon is also for the October 20th class. And I wonder if I should really prepare myself for the, and we're going to go more deeply into quantum.
No. Well, the idea is during this general period of time, you should be getting through Jack's videos, right? Or video, depending upon how you wish to do that. I mean, if you want to watch them all, there are like maybe up to 100 videos that yeah. But the content really over the 9 years hasn't changed very much. And the basic, like he was a consultant for IBM one year. I think that's the reason that some of these have such a high number of views. And toward the end of one of the lectures, he has this thing about all the textbooks will be rewritten. Like they're not written in a quantum way now, but eventually they'll all have to be, and so on. So the IBM people really got into that, and they told all the people who were involved in Jack's consultant visit that they should watch that part of the video, and it went on. And that general advice then, filtered through IBM for years afterwards. So that's why there are like 6,000, 7,000 views of the video. Yeah, but I don't think that means that it's not valuable to you. Obviously, if IBM thought that highly of what he was telling them, then you might also think highly of it. And it's somewhat timeless, exactly because it's not mainstream yet, right? It seems quite hard to explain many of the concepts of quantum to you. And in your conversation with the other people that you know in your life, you're not getting into this very much. Like the number of days when you talk about quantum tunneling and superposition, it is probably limited. You may have never had a conversation about those things with anyone that you know, right? But the time will come where it is more mainstream, and therefore I think what Jack's done a little bit is to expand on the details as we went from one lecture to 4, but that doesn't mean that it's the 2020 advances. It might not be. A lot of the references are still back to some years ago. Well, going back to the Solez conference, whatever that famous picture in the first few slides are of all those Nobel Prize winners, right? Yeah. So I think it'll be different for each of you, but this part of the course will have many memorable facets for you, and may give you ideas that will be a solution to something for you in the future. So anyway, that's my story. Yeah, so I mean, I have sometimes talked about what happens to students in this course who just coast. I already know that none of you fall into that category. You're not just coasting, not just sitting here and doing nothing, because that would be no fun at all, because the other students are so cool and, you know, engaged, that if you were the one person not, but like if you didn't do anything, you would find that you may still know enough to answer some of the quantum biology questions, because they're quite easy. So so that really isn't the point. The point isn't for you to learn enough to answer 4 out of the 7 quantum biology questions. It's for you to learn enough in this area for, you know, your future, right? So that you're a cool person to ask at parties, because when the really deep conversations start occurring after 10 p.m., you're like more interesting to listen to than anyone else there, you know? And so that would require doing more than just learning enough to be able to answer the 4 out of 7 questions on the midterm. Yeah. So does that make sense? Yeah. So you have to decide, you know, your contract with me is pretty simple and limited. Your contract with yourself, though, is like deeply detailed. You have to look in the fine print and see what the latest agreement you've made for yourself about what you're going to accomplish and learn and stuff. Yeah. That will enter into, so you're asking what you should do between now and Tuesday. And whatever you're doing, it's not because I require it or Simon requires it, but that contract you're making with yourself may require it. Okay. All right. Very good. Well, I think we could probably let you go. Is there any other burning questions that any of you have? And thanks again for Taryn for telling us about ghosts. Yeah, that's good. Okay, so have a great weekend, guys, and we'll see you on Tuesday at 3 o'clock. Okay, take care.